Everyone, welcome back to Seneca A-level chemistry revision. Today, I am going to be running through empirical and molecular formulae to get you up to speed on everything you need to know for your A-level exam. So, let's go. What are we waiting for? The empirical formula is the simplest formula for a compound. The molecular formula gives the number and types of atoms in a compound. So, empirical formula, think of that as the simplest whole number ratio of atoms in a molecule. And I would learn that definition. It can definitely come up on your exam. If we go through an example, we have ethane that has 2 carbons and 6 hydrogen atoms. So the empirical formula would be CH3 because it's the simplest whole number ratio. 2 goes to 1 carbon and 6 hydrogens goes to 3 hydrogens. The molecular formula is the actual number of atoms of each element in a molecule. It is always a multiple of the empirical formula. So ethane has 2 carbons and 6 hydrogen atoms, so C2H6 is the molecular formula, and the empirical formula would be CH3. Now, the empirical formula of a compound is often very easy to determine experimentally. You hear that? Very easy. So, for instance, you could combust a hydrocarbon and find that you get twice as much water vapor as carbon dioxide. This would tell you that its empirical formula is CH4. Remember, H2O contains 2 H atoms. Don't let that catch you out. So a molecular formula is relatively difficult to determine experimentally, though. So we are all about that empirical formula. So molecular formula shows the actual amount of atoms which make up a molecule. Remember that. Whereas the empirical formula, that is our simplest whole number ratio. Do you remember the empirical formula for ethane? Is it C2H6? No, it's not. It's CH3 because it's empirical formula, so we want the simplest whole number ratio. Now, I said it was easy to experimentally determine the empirical formula for a compound. I am a man of my word, so I'm going to go through an example. So, let's say we have an alkane. So an alkane is something that has no double bonds and just carbon and hydrogen, and we burn it. We make 3 moles of water and 2 moles of carbon dioxide. What's the empirical formula? So, first things first, we calculate the number of moles of hydrogen atoms in the water. 3 moles of water is going to contain 6 moles of hydrogen atoms. Remember, no excuses, water has 2 hydrogens, so we double the amount of moles of hydrogen. Now, we then calculate the moles of carbon atoms and carbon dioxide. 2 moles of carbon dioxide contains 2 moles of carbon atoms. Then we can look at the ratio of carbon to hydrogen, which is going to be 2 to 6, and this simplifies to 1 to 3. Remember, we want the simplest whole number ratio, so our empirical formula is CH3. See, that wasn't so bad. I hope you're feeling confident about empirical and molecular formulae. Keep up all your hard work and studying. Best of luck with everything in life, as well as chemistry.